Welcome back. So adding and subtracting rational polynomials. We have done a few videos now on these rational polynomials, from kind of going and factoring them out and then being able to see how to multiply, how to divide, how to set restrictions on them. So now the last item, I guess, within here is going to be just adding and subtracting them. Now within rational polynomials, if you recall, so you see here just a basic fraction, you will remember that in order to be able to add fractions, and I'm not going to go into much detail, but I just want to be able to kind of deja vu for you, we needed a common denominator, right? So in order to be able to add or subtract, we always wanted to have a common denominator. Now, how to find those common denominators, of course, for fractions. If you want, here, I'll put up a link, I guess, up above to those fractions. You can take a look at that as a refresher if necessarily you want to, but I'm going to assume that you know how to do that. So if you do have a common denominator already, ideally it's the lowest common denominator you can find, then it's not really a big deal, because all you do is you just add the numerators, right? So within here, so our answer would have been just 6 divided by 4, and then we can reduce this if we like, 3 over 2, or put it as a mixed number. Now, I want you to keep that in mind, because when you're dealing with rational polynomials, nothing really changes. The ultimate goal, although we will not know what our x or what our variable that we will be dealing with is, it doesn't matter if it's an a y, whatever, the denominators have to be identical in order to be able to add or subtract these rational polynomials. So just like here, when we have our regular fraction, that's what we want to be able to see within our denominators that are, for example, some rational polynomials. So within here, so notice I have an x plus 1, and I have it under both terms. So these two terms that I have, so this one right here, which is one term, and then here is another term, I can just go ahead and add it, or if it was subtraction, I can subtract them. And I do the same thing. I basically, once I have the denominators and they're common, then all I do is I just deal with the numerators. So in this case, what I would have is this 1 plus 2 is just simply 3. And then my common denominator, because I have it for both, doesn't really change. So that stays identical. And this is the concept that you want to be able to see. So again, if you're very comfortable with fractions in general, it shouldn't be a big leap of faith to try to do this with rational polynomials, because what you're going to be doing is you're going to be just finding your lowest common denominators, or sometimes just denominators in general. So if I kind of scroll this through and make it even more complicated, so for instance, within here, so I have now a subtraction, and notice that my denominators, so unlike in the previous example, so they're not the same, right? And what do we do when they're not the same? For example, if they were just fractions, well, we find the common denominator, or we find the lowest common denominator. And there's ways to do that, and you can see that in that link that I pointed out in the beginning. But within these, because we have numerous factors in the denominator, so I have two factors here. So for instance, I have the factor of x plus 1, and I have another factor, 2x plus 1. So those two are multiplying. And most of the time, it may not be factored out for you, meaning the denominator. It could be just the regular quadratic or some kind of a polynomial of higher order. Now, for now, we see this example, and it's basically factors that are already factored for us. Now, in the second term, what I have two factors again, but they're different. They only share one common factor. Now, that common factor within here is basically the x plus 1. And the 2x plus 1, and then on the other term, which is the x minus 1, those are not in common. So how do I find a common denominator? Now, ideally, you want to be able to find the lowest common denominator. So what I would do is I would simply say, all right, well, these first two factors, so this one right here and this one right here, so the x plus 1, that's common. So I'm going to set this up, and I'm going to say that this factor is common to both. Now, the factors that are not common to both, I also have to put within here, because that would have been kind of like finding the lowest common denominator. So I'm going to take this one from right there, and I'm going to take this one from right there. Those are the common denominators that I need, or sorry, the common factors that I need in order to find the lowest common denominator in between those two that I have, those two denominators. Now, once you do that, you have to also change the numerators. So if you're going to, for instance, have this and this, now this is already there. So notice I have these two factors right here. I'm going to kind of switch the colors. I already have these, but I do not have this one. So my 3x right here, I would have to multiply. So I'm going to take my 3x, and then I'm going to have to multiply it by the x minus 1, so that that term is not changed. Notice, if I simplified this, right, if I would simplify this, then the x minus 1 would cancel, and then I am back to this term as I start. And that's the goal, right? That's what you were doing in fractions, except you were doing it with numbers. So it was a little bit easier. Now within here, now of course I'm not going to be canceling these out because I'm trying to find the common denominators. Now I'm going to do the same thing to my other term. So now I have this 4. And now, okay, so what do I have? Well, I have my x plus 1, and I have my x minus 1 right here. So I have these two. So okay, so that's fine. So those are the two that I already had. But I added this one right here, and I will have to multiply it right there, okay, to keep that term the same. Now that I have a common denominator in between, now I can go ahead and subtract this, right? So now this subtraction process, I mean, of course, it gets a little bit of annoying, because now what would we have to do? I mean, we can distribute and then we can subtract altogether. So for this, if I really wanted to complete this, so I can say this is 3x now squared minus 3x, the negative. So what I did was I just brought this inside. I'm going to bring this inside as well. That's going to give me negative 8x minus 4. The denominator is going to stay the same. Now, you can certainly distribute the denominator, but because I have 3 factors, it would make this pretty lengthy. So I typically actually just leave it in factored form. So I don't really change anything. I just leave it like that. I'm going to copy it and then paste it in here. That's my denominator. And then I can check if I can, do anything with the numerator within there. So my numerator, so the 3x squared will stay. And then what I would do is I would have minus 3x minus 8x. So those are like terms. So it's going to become negative 11x. And then minus 4. And then I would leave it at that. I mean, you can write it up in there. I'll just leave it the way that it is here. But I will just collect those like terms. And then that's it. So now you found your common denominators, and you can subtract the two terms as you like. Now, do you have to factor out the numerator now to see if anything cancels? Sure, you can try that. And we have done those, and that's basically going back to multiplication and division, and then trying to see if we're going to be needing any restrictions within here. Now, that's one thing that you didn't have to worry about when you were dealing, for example, with just simple numbers. There really weren't any restrictions. In here, don't forget that if this expression had to do something with functions, and then you had to create a function which was the addition or subtraction of rational polynomials, you would have to restrict your actual denominators so that your x is set such that the denominators do not equal to 0. And now within here, so if I would go back, okay, if I was dealing with the original one, so I can go back to the restrictions, so right here, and I can start them off. And notice that from right here, we would have the restriction that x cannot be equal to negative 1. Right? So that would be here and here. That I would also have that x cannot be equal, and that's coming from here, would have been negative 1 over 2. You can check that. And then from here, you would have that x cannot be equal to, and that is 1. So those would have been restrictions if you were dealing with just functions in general. If you're just dealing with expressions and someone's asking you to add and subtract them, you can go ahead, find the common denominator, and then proceed. But don't forget, if you ever have to set restrictions, you can do that. And you can watch the video. I've done quite a lengthy video in terms of examples on those restrictions. I'll put that up above there so I don't clutter this video too much. I'm going to try to avoid those restrictions within here. I'm just going to focus on the denominators and adding and subtracting. All right. Okay, so now if we know this, can we tackle many more examples? And of course, the best way to kind of study these things is, you can pause the videos and then try to see if you can set the denominators and then add and subtract them as you please. So let's try these kind of one by one. And I have a few here, and it will make the video a little bit longer, but so be it. All right, you can skip any ones that you like, or you can just go to the answers, once you feel comfortable. But I'm going to walk you through as many as I can and point out certain things along the way. So here's an example. So we have the subtraction, and we have 3x over x minus 1, and then that's 2 over x squared minus 1. So my first step will always be, okay, so I have my denominators right here. If I can, so in this case it's a quadratic and it's actually a difference of squares. So I will, if it's not already done for me, I will try to factor as much as possible. So this one, there's really nothing to factor because it's already done. And this one, however, I do have my difference of squares, so I can do this. And from here, what I notice is that, oh, okay, so these two factors are in common. So I'm not going to have to repeat them. And now if I'm going to be setting my denominator, so my lowest common denominator for this, so I'm going to take this is going to be my first factor, so let's say x minus 1. And then my second factor will just be this one, which is x plus 1. And if I wanted to distribute that across, it's going to bring me back to this difference of squares right there. So that is my denominator. Now, for here, so what I do is I have 3x, and that 3x is going to stay right here. And what did I change? Well, the only thing that I changed is now I have the x plus 1 factor, which I added to my denominator. So I'm going to add it there, and that's just multiplying. Minus, now I don't have to do anything here because the denominators are identical as they were. So this is just going to stay as minus 2. And now I proceed in the same way. So I'm going to have 3. This is going to be x squared plus 3x minus 2. And then divided by, and this is x minus 1, x plus 1. All right? So that's what I have right there. Now again, you can check, does this factor out in any particular way? You can try to see and play around with that. I'm going to leave that up to you. So it will depend on, what your teachers want. If they want you to factor the whole thing out, you certainly can try that. Now that's a quadratic, and you can check if that quadratic is actually factorable. I mean, you can even use the quadratic formula to very quickly check, or even sketch it for yourself if you like, using Desmos to see if you actually have roots there so that you can properly factor it. All right. And my idea was here is, okay, so how do I find these denominators? Okay, and this is how we do it. So I'm going to leave it at that. So that's my first example. Here's another example that I have for you. So for here, this one is a little bit longer. So it's example number 2. But this one is factored for us. So it might be a little bit easier. So here we go. I'm going to switch my pen color. And this is what I have. Now, what happens when you don't have anything, so any factors in common, right? And this kind of should remind you of, what if you had something like this and you wanted to add it? And really, these two denominators are prime numbers, so 3 and 5. There's nothing in common. So what do? You kind of might remember that we used kind of maybe cross multiplication in a sense, but what we were doing is we were just multiplying, right? We would have 3 times 5 as our denominator, and then we would go 5 times 1, that's 5, and then 3 times 1, which would be 3, and we would have 8 over 15. That's what we would do. And that's exactly what you do when you have addition or subtraction of these rational polynomials, when the factors don't have anything in common. So you're kind of forced to basically create a very huge denominator in general and proceed that way. So our denominator for this indeed is going to be rather big, right? So we have all our factors. So I'm going to put them in. So 2x plus 1. X plus 4 is the first one. And just as we did with the 3 and the 5, we have to multiply them. So here I'm going to multiply this, and I'm going to get this enormous denominator right there. Now, in the numerator, well, what we do is we would have this 1 multiplied by these. So that's going to be x plus 2, and then 3x plus 1 plus, so that's our plus, and then 1 times these two right there. That's going to give me 2x plus 1, and then x plus 4. And as you can see, it becomes quite a mess, because now you're going to have to try to simplify this in any way. Now, and if your teachers are mean to you and they want you to distribute this across all the way, I mean, that would be quite a pain, because you would have to go kind of one by one and then proceed on to try to simplify. And then again, you would have to do the same thing here. So what I mean is you would have to take your x plus 2, so this right here, I'm going to copy it or maybe duplicate it, and now I have to get what that answer is. Well, what is it? This is going to be 3x squared. So I am just multiplying it through, so distributing, plus my x, then it's going to be plus 6x, so that's these, and then plus 2. So I have 3x squared plus 7x plus 2. So that's the first one. That's this right there. And now you would have to do exactly the same thing right here. And if you do that, you're going to get another quadratic, and then you're going to be able to add them up together, and you're going to have one particular line. I'm not going to go any further than that, because I think distribution, an addition of polynomials, you should be comfortable with by now if you're watching this video. And, if you've forgotten, just basic addition of polynomials, I can put up a link up above there kind of as a refresher, which also deals with the distributions. All right, so I'm not going to go any further here, but it will depend on your teachers how far they want you to take this. All right, so that's another example of how to find, these denominators. So here's another one, which is going to be our third one. Now, what happens, so within here, I'm going to copy this, and things are not factored for you. So, you're kind of stuck. You're dealing with this ugly subtraction that you have within here. You're not sure if this is really factorable or not, so how can you quickly tell? Well, there is really no quickly in anything, and it will depend on what tools you have in order to be able to factor, right? So if I'm doing this for homework, or I'm doing it on the side, it's not really for a test, and I am actually allowed to use, tools to help me along, what I would do is, well, both are quadratics. So I know quadratics are going to be basically just parabolas. So I'm going to see if these parabolas actually cross through, so that I can get zeros out of them. And if I can, then I can try to quickly see if I can factor this out in any way. So I'm going to use decimals, And if you can't use decimals, you're going to have to you can use the quadratic formula. Put up maybe a link above there to the quadratic formula if you've forgotten it in some way. That's probably the quickest way to see it. I like to kind of just plot it up on decimals to get a quick look, So I'll be right back. All right, so here it is, So I just plotted it up. So that was the first one that I had. I'm going to do this one as well, which is the second one. So very quickly, just to see. All right, so I have two parabolas, and notice they're both going. So they're going to have some zeros, right? So I can kind of blow this up within here, and I can kind of tell. One is negative 1.5, and it looks like both of them are going to be at 2. So that means I can actually factor this whole thing out. This is going to have very nice factors, and that's how I can quickly tell. All right. If the parabola didn't go through the y is equal to 0 point, that means we wouldn't have any. of them. Okay, so that's a quick check for myself. And now, all right, so I'm going to then try to quickly factor this out. Okay, so let's see it. So 3 times 4, so that's 12. So that's going to be negative 12 actually. And now I'm going to get two numbers that added together give me negative 4. And so for that, I guess it's going to be minus 6 and 2, right? Because if I add this, gives me that is what I want. All right, so I have, so this becomes, so 3x squared minus 6x plus 2x minus 12. And I can now group these together. So I'm going to group these together as so. So 3x is going to give me x minus 2. And this is going to give me, I guess, right here. So I have, and so 2x and then, sorry, minus 12. It's a boo-boo there. Okay, it's minus 4 right there. Okay, so I have take out the 2, and then this is going to be x minus 2. So this in factored form is going to be that. Now you might say, well, you've already graphed it. Why don't you just take it that way? You could. You can certainly do it that way if you like, in terms of taking it out. Okay. But I also like to factor it for myself just to quickly kind of get a gauge to see. And here, I'm going to do the same thing. So 2, and so this is actually also minus 12. And now for that, and then so I have negative 1 right here. I guess that's going to be negative 4 and 3. All right, so that's what that's going to give me. So therefore, again, so grouping them together, maybe I'll use a different color. So I'll get 2x squared minus 4x plus 3x minus 6. So that's that. So let's group these like that. And we're going to get, so 2x, x minus 2 plus 3, x minus 2. So this gives me the other denominator. And now I can rewrite this whole thing again. So x plus 2 all over. This is going to be 3x plus 2, x minus 2, minus x minus 1 divided by 2x plus 3, x minus 2. So I have now everything in factored form, which is kind of the previous example, and now I check. Well, here I actually have a common factor in between the denominators. That's what it is. So setting a denominator, a lowest common denominator, so I'm going to do that. And then set 3x plus 2, so that's this one. And then finally 2x plus 3, that's this one. So that covers all of them for me. So that's my denominator. And now I can go ahead and proceed with my numerator. So I have x plus 2. I'm going to put it in brackets. Now, what did I add in here? Well, the only thing that I added was the 2x plus 3. So that's going to be right there. Minus, so minus. Then x minus 1. Now, what did I add there to that one that I didn't have? That was 3x plus 2, as the rest was common. And now you just go ahead and you expand, collect like terms, and you're done. All right, so again, I'm going to leave it up to here because the rest is just routine. And this is how you would kind of add, in this case, subtract these rational polynomials. All right, so that's another example that you see. I think it's a pretty useful one to be able to gauge, and you get comfortable in finding these denominators for these rational expressions. All right, here is the next example. So we've covered this one, we've covered this one, we've covered this one. Now we have, so here's another one, okay, right there. So let me copy that, which is our second last one. All right, so this is what we have. And so now in this case, so again, if you can use a graphing tool, Desmos, to try to see and plot it, to see if you actually will be able to factor this out or not, great. If you can't, again, you can use the quadratic formula to see it, or you can just try to see if you can factor it yourself. Another kind of thing to think about, don't forget that quadratics you can always put into the vertex form. And then from the vertex form, it's much easier to be able to tell if the parabola goes through the zero, if it has zeros or not. All right? Okay, so that's something that you can think about. So those are the tools that you have, from kind of grade 10, right? And then from those actual tools, you can do quite a bit with these quadratics. Okay, so for us, so what I can do now is let me bring back Desmos within here. So I'm going to bring it back, split the screen here so that I can have it. I'm going to remove the ones that you see from the previous example. And so what I'm going to do is I'm going to do it kind of two ways. All right, so 2x, now this is squared, minus 4x plus 4. All right, so there you go. So you see, this is the parabola. It does not go through the y is equal to 0. So this actually will not give us any real factors that so we can't factor this out in any particular way. So we're kind of stuck. Now the second one that we have, so this one right here, we can try the same thing. So x squared, okay, minus 4x minus 5. Well, this is another parabola. Now we kind of would know that it's pointing down because it's negative there. But we can see that this also doesn't really pass through the y is equal to 0. So we can't even factor this out either. So if you can't factor things out, then what do? Right? So we can't really factor this out in any way. And if you would like, you can try the quadratic formula for yourself, plug the numbers in, and then you'll see that you won't actually get real factors out. So I'm going to move this out of the way. So in these instances, when you are facing something like this, what can you do to add them, right? Well, the only thing you can do is this becomes your entire big factor because you can't really factor anything out. So what we have to do is we're going to create, so our common denominator that we will have in this case, well, this is one big factor, unlike the other ones where they were very nice. That's one of them. Now we're going to multiply it by the other denominator. And unfortunately, it's very ugly, but that's what we would do. Now, sure, you can distribute, you can simplify, collect like terms. I mean, I typically just leave it in this particular way. And then on the numerator, so what I would have is I would have x multiplied by the negative, so basically by this, negative x squared minus 4x minus 5 plus, so that's the plus right there, 2 multiplied by all of this, which is 2x squared minus 4x plus 4. So it should remind you of basically the same thing of addition and subtraction of just regular fractions, right? Because fractions are just rational numbers. And now from here again, it's up to you how far you want to be able to push this for yourself. Now this one is kind of ugly. I mean, it will be a quadratic, I guess, when you collect all your like terms, so it won't look that bad in the numerator. In the denominator, I would actually just leave it. All right. So I wanted to give you this example to show you that it's not always very nicely factorable in the denominators, and then you're kind of stuck and you have to do something like this. All right, so that's another example. The last example that I have for you is, so far we've been just dealing with two terms, right, and just constantly finding it. It's just like having two fractions. But as you know, what if you have 3 fractions or 4 fractions? Then what we had to do is we had to find a common denominator for all of them. And that is, it was a pain just with numbers. Well, it's also a pain when you're dealing with these rational polynomials. So here is an example, for example, with 3 terms. So I have term number 1 right there. I have term number 2 right there, and then I have term number 3 right there. And since they're adding and subtracting, I have to find a common denominator. So, what do I do? Well, this one is nice. It's just x plus 1. So this one right here, this is a difference of squares. So this is going to be x minus 1, x plus 1. This one is factored for us. So great. So now, if it's 3 denominators or 4, you do exactly the same thing. So finding a common denominator in between them, you have to take all your factors. So x plus 1, right, that's coming from the first. Now I do have the x plus 1, so I don't have to repeat it. Okay, so I have it here and here. So that's one of them. Now the x minus 1 we will need, so that's from right here. So far I have this covered, I have this covered. Now here's an x minus 1 here as well. So notice that. So I have x minus 1 here, and I have x minus 1 here. So I only need one of them. So that's what I have there, and then my final one would have been 2x plus 1. So it's not as bad. It has 3 factors. And now you have to worry about the numerators. Now for the numerators, well, this is 1. The x plus 1 was already there. So I have to go 1 times x minus 1 and 2x plus 1. So that's from right here. Okay, so that 1 times that really will just disappear. So that's the first. Then it's minus, so that's minus. Now, put this always in brackets, all right, within here, because you want to properly know that that is the numerator. Now, that numerator, I'm going to have to multiply by 2x plus 1, which I didn't have in the denominator, and then plus, finally, 5 multiplied by, and it's x plus 1. That was the only thing missing there. All right. And again, so now you can take this entire thing. So you can take this. You can simplify it as much as you like. So meaning you can distribute, you can collect like terms in the numerator, and you'll have what you need. And then you'll have your denominator as well. All right, so that's as far as I want to be able to push this. I think that it should give you a good kind of gauge and several examples to try on your own to be able to see if you can add and subtract and find the lowest common denominators for these rational polynomials. All right, we'll see you in a future video. I hope that this helped just a little and prime you for your grade 11 math courses. Okay, bye everybody.